All right, class, let's move on. Now, we're going to talk about something called significant figures. They're really important because significant figures help us report how accurate and how precise our measurements are. This is an important definition. I'd like you to know it. Significant figures in a measurement consist of all the digits known with certainty, plus one final digit that isn't known for certain, which is somewhat uncertain or estimated. This term significant does not mean certain. It just means significant. All right? Are there have we done this last year at all, significant figures in biology? I don't think so.
It was physical science.
Physical science? Okay, so this should make a little bit of sense. I'm going to turn my camera on, and I'm going to show you what that means exactly. All right, so what we're looking at right here is a triple beam balance. It should be coming into focus anytime. A triple beam balance is a unit is a tool to measure something. What? Measure mass.
Sorry.
In the way that by measuring the pull of gravity on an object. All right. So here let me delete this thing. Clear ink. So here we've got a little marble chilling out on the pan, and it's sitting in a little tray. It's the same thing you did last time. Yeah, there it is. So, all right. The question then is, the question is then, okay, let's try again. The question is then, we want to know how accurate this device can be said to be. Well, what is the smallest known mark on the balance?
Nada.
Well, yeah, there's the smallest mark, so it starts at 0. What's the highest mark?
10 grams. Wait, no. What's the one with a smudge on it?
This says 100 right here, and this one says 500, and this one says 10.
Grams.
So you could bring it all the way up to 610. Now, here's another question. What is the smallest increment of measurement?
I would say
0.01. Is there anyone else who would like to say? 0.01?
No.
0.01.
Another.
How about just point?
This one? This one. Okay, so one person says 10 hundredths, it'll measure to a hundredths of a gram. Another one says 10 hundredths thousandths of a gram. Anyone else have an opinion? Kara says 0.1 of a gram. Well, actually, the right answer is 0.1. Check it out. Right here goes from 1 gram to 2 grams to 3 grams to 4 grams to 5 grams, and in between each number are 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one represents 0.1 of a gram. So we can say that this device is precise up to about 1/10 of a gram. It'll give you that kind of precision. Now, what was significant figures? Let's go back to our screen. Significant figures was a measurement consists of all digits known with certainty plus one final digit, which is somewhat uncertain and estimated. So whenever you make a measurement, you go and you check out to the measurement of certainty and then guess one more. So let's go back to our screen, our screen right here. What is the digit of certainty? What is the measurement of certainty? Well, we're using we're using grams.
You gotta do it on the side again.
Do I?
Yeah.
Okay. All right, so we're using grams. I'm just going to talk without, that's better. All right, that's cool. I can see clearly now, the screen is on. Okay, so imagine with me, because I can't use my pen, Imagine the number we know for certain that it will measure in tens of grams. We know for certain that it will measure in hundreds of grams. And we know for certain that it will measure in tens of grams, tenths of grams. The next level of measurement is 1/100th of grams. That means in between these little spaces right here, we don't know. That is where our accuracy stops. We can't be accurate farther than tenths of grams. So how do we make a measurement? We would say up to what we know plus 1 we guess. So this says 7 grams, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 7.9, and then we guess. What would you guess, Timmy?
0.2.
So
7.9.
7.92, absolutely. What would you guess, Nigel? 7.93. And Vanessa? All right.
7.98.
Okay, you might be disputed, but your answer is not wrong because that is your guess. Okay, so 7.9 is, no one's doubting that, but then that extra one is the guess. That is significant figures. So it can be said then that that measurement has 7. Okay, that measurement can be said to have 3 significant figures. 3 significant figures. Does that make sense? Okay, one of which is guessed at, 7.92 or 3 or 8. Okay, so without further ado, let's go back to our presentation. Are there any questions about significant